Welcome back to another edition of Sustainability TV. Today we're going to be talking about film development at Brückner. And for that, for part one, let me welcome Dr. Markus Koppers. Hello, Markus.
Hello, Peter.
Let's start off by talking about the Technology Centre here at Siegsdorf. How would you describe it?
I'm coming from packaging industry, and when I started at Bruckner, I felt we are the workbench for packaging industry. Here we can realize many film prototypes and even packaging prototypes, but we are not only working on packaging applications, we also have in focus technical film applications. And so we have to say we are the workshop for technical film applications because batteries, capacitors, they're impossible without special designed films. And these we can make here.
Markus, what facilities are available to you and your clients?
We have everything which is necessary for stretching. So typically we start with a small extrusion line already for multi-layer film extrusion. And films produced there, we test at our Caro lab stretcher. And there we can make small film samples and we can check how the film behaves in stretching. And after we have done that, we are ready to go to our lab line. And on the lab line, we can test everything what the customer wants to see for making in production. And we can check in sequential, simultaneous stretching mode. And afterwards, we have our lab to check the quality, to make a quality control of the as-produced film. Mm-hmm. And we can also use with our chemical and film analysis lab the opportunity to check films on the market, how they are composed, how are the quality of the raw materials. So we have everything to check what we are doing in film extrusion and stretching.
Mm-hmm. Especially with the need for a circular economy and new monomaterial solutions, the Brückner Technology Centre has gained even more importance within the film and packaging industry and also the entire value chain.
Exactly. In the past, packaging was just defined by price, lower price, and lowest price. So what we did in packaging industry, we used the cheapest films available, having the best performance, and at the end, we ended with a thin, perfect polyester film, a thick polyethylene blown film, and had everything the market wanted already available. This is not possible anymore because such solutions are not recyclable. And we try to substitute, for example, the polyester film by a special made BOP, and I'm quite confident we will succeed on this way.
Could you give some examples?
A packaging always needs a barrier, it needs mechanical protection, and it needs sealability. And important for our stretching process is barrier and mechanical strength. And if you have just one material available, you always have one option, and if there is mechanical strength by the PE, then we design the barrier with our inline coating, and by this we are improving the options for packaging industry to make monomaterial design. And we are going the way that we try to go a quadruple way: monomaterial polyethylene, monomaterial polypropylene, polyester, and even biopolymers. But packaging is not the only thing we work on. For sustainable technical solutions, we are working on battery components like separator film, current collector, ultra-thin capacitor film for high-efficiency capacitors in car industry, and also of high importance are electrical insulating solar backing films.
Mm-hmm. In addition to your own trials, the Technology Centre or facilities within can be rented. Who makes use of this offer and how does it reach the market?
Oh, we are completely overcrowded in 2023. So there are quite a lot of players from the market trying to get a slot for testing their raw materials or trying to make new films or trying to enter into new applications. And mainly we can say the first are our customers buying a line. They need to set up the line and new products, and we just support them. Secondly, we have raw material suppliers supplying the source for our customers, and they need to be ready on the market. They need good material, so we serve them, and by this also our customers. And last but not least, the whole packaging supply chain and also technical companies are developing together with us. And this is something we are very proud of.
So much today for the obviously incredibly successful Brückner Technology Centre. Markus, thank you very much.
Thanks, Peter. It was a great pleasure to me.
Now let's talk about the use of recyclates. And for this, I'm very happy to welcome Sabine Weber. Hi, Sabine.
Hello, Peter.
Apart from the topics of recycling of packaging and circular economy, there is the growing use of recyclates in packaging. That's another topic in the EU and individual countries. Brückner wants to be optimally prepared for the usage of recyclates in biofilms. What are the main activities of the company in this field?
Since there have been so many activities and projects in the last years, I would like to focus on just a few. I would like to mention our joint projects in several corporations. Number one is R-Cycle. R-Cycle is a cross-industry community providing a global open standard for tracing plastic products, a so-called digital product passport. At the end, this makes the precise sorting of plastic waste possible. Number two is Prinzig. Prinzig is also a project with partners from the supply chain. And in Prinzig, we investigated the influence of printing inks on the process of mechanical recycling and on the quality of the recyclates. After several trials, we were even able to recommend a certain type of inks which is very suitable for the mechanical recycling, and we could produce really high quality recyclate which is suitable for high quality films.
Did these recommendations prove to be viable in practice?
Oh yes, by bringing the two projects, Prinzig and R-Cycle, together, we were able to produce crisp bags for demonstration purpose. This crisp bag is designed with recyclable or recycling suitable materials, for example, the right ink system. And these crisp bags were mechanical recycled, so we got this recyclate, and Brückner produced a BOPP film which contains 30% of this recyclate. So this film has very high mechanical properties as well as nice optical properties. Another interesting finding from this project was also the production of new pouches using the recyclate containing BOPP film. We call it second life pouch. And we found that pouches made with this kind of BOPP film, so this second life pouch fulfills the requirements which are needed for food package. So theoretically, the BOPP film could be used for food packaging, but at the moment, so far, it is not allowed in the EU to use recyclates for food packaging. And what we have also seen, the use of 30% of recyclate can reduce the carbon footprint, the CO2 emissions of a package for more than 20%.
Great. Are there any more corporations you want to tell us about?
Yes, for example, very actual is our joint project Plastic Bond. This project brings together research institute for plastic processing, suppliers of plastic processing machines, producers of post-consumer waste recyclates, consulting companies, packaging producers, and many more. One goal of this project is a sustainable optimization of plastic packaging by the use of digital technologies. For example, the development of a platform to get resilient data about the use of recyclates. And we also want to find correlations between the characteristics or the characteristic profile of recyclates and their processability. So we test different additivated recyclates to get more details, to get more experience, and then have a platform where you can get all the information which are needed.
Mm-hmm. With all these projects and research, one question naturally arises: how can we use more recycled plastics?
So ecologically and economically, recyclates are a really challenge in balancing costs and benefits. Mm-hmm. Recycling is a quite complex process in terms of material, high specific processes and process parameters. And recycling needs ideas regarding processing tolerances, homogenization, additivation, material characterization. So finally, the procurement possibilities must be given from the market. Altogether, we are in the middle of a process, and we are still finding out what is really possible and what really makes sense.
So thank you very much for these interesting insights into the use of recyclates, and for that, thank you, Sabine.
You're welcome. It was a pleasure for me.
We've talked about the Brückner Technology Centre, we've heard about recyclates, and now we're going to find out more about polymers. And for that, I welcome Dr. Martin Wolf. Hi, Martin.
Hello, Peter.
To be precise, we're going to be talking about biopolymers. How exactly do you define these materials?
Yeah, the definition of biopolymers is in fact rather wide. We consider polymers which are biodegradable and or made from renewable resources, like for example sugarcane or corn, as biopolymers. So a typical or well-known example would be the so-called polylactic acid, in short PLA. And this material is bio-based and biodegradable.
So what are then the benefits of these materials compared to their fossil-based counterparts?
Yeah, most of these biopolymers are made from renewable resources. This means that the plants which are used for their productions, for example the sugarcane, has been capturing carbon dioxide from the atmosphere during their growth period, and thus giving us kind of, let me say, a carbon dioxide credit. But of course, we have to watch the whole production process very closely, and also the end-of-life options, such, for example, like composting, mechanical or chemical recycling, to keep as much as possible from this credit which we have been given. And so in this way, biopolymers can help us to generate new and sustainable packaging solutions next to recyclable and reusable options. And another benefit of biopolymers can be found in certain applications, like for example as food packaging used during huge events like sports events or music festivals. Because if you collect the biopolymer packaging waste together with the typical food residues together, then you can dispose of all this waste at a nearby composting facility without any need for energy intensive cleaning or separation steps. And at the same time, you are saving plastic materials and avoid waste in general. And there are even some legislative incentives which are discussed right now, which are under discussion right now in the European Union, meaning that certain products, like for example tea bags or coffee capsules or labels attached to fruit or vegetables, should be in the future made mandatory from biopolymers.
Well, all that sounds very promising, but why isn't then everybody using these biomaterials?
Yeah, well, unfortunately, there are some other points which also need to be mentioned, because if you're producing polymers from plants, then you need not only to consider carbon dioxide emissions, but also additional parameters like, for example, land use or water and fertilizer usage, depletion of soil or competition to food production. And these are unfortunately all parameters which are very, very hard to quantify. And second, this is regarding the end-of-life options of biopolymer packaging solutions. Right now, at the moment, there are no collection schemes or sorting streams for biopolymers available. So this means there's always the danger that biopolymer waste goes into the wrong sorting stream, let me say, into PET or PE streams, and thus contaminates them. Or in the worst case, that the biopolymer-based packaging waste goes together with the other normal domestic garbage into combustion. And this is, of course, not what our target is.
So to sum this up, the use of biopolymers is not in every case more sustainable than the use of fossil-based polymers.
Yeah, that's absolutely right. It's essential to consider all factors and parameters for a certain packaging application and then decide, in the best case with an LCA, a so-called life cycle assessment, which solution is really better for our environments. And finally, there are two other critical factors regarding biopolymers. The one thing is the currently still very limited availability on the market. And the last point is the price, which is in most cases not competitive to their fossil-based counterparts or fossil-based polymers made from oil or gas.
Then why, this is the question that arises, has Brückner Maschinenbau made so much effort for so many years to develop bio-based packaging solutions?
Yeah, because despite all current issues and obstacles, we think that in the future biopolymers can play a decisive role in generating new and sustainable packaging solutions with improved properties and with optimized disposal options, either in a bio-based circularity or via other recycling possibilities like chemical or mechanical recycling. This is absolutely our conviction.
And what exactly is Brückner's contribution to the development of bio-based packaging?
Yeah, we are working here on several projects, either for our own internal basic research or together with partners from the packaging added value chains. Sometimes we are even performing some semi-industrial production campaigns here on our pilot line for partners and customers. And one project I'd really like to mention is together with a very well-known company, PepsiCo. So there, among other things, their scientists are working on home compostable, bio-based packaging solution as an additional route to achieve their ambitious sustainability goals. And together we have been doing numerous trials here on our pilot line. And this is always more or less like a science festival, let me say, because PepsiCo brings together scientists, film producers, raw material experts from all over the world here in Siegsdorf. And all these experts are teaming up, are bringing together their expertise to achieve the common goal of a sustainable food packaging solution, which of course needs to be beneficial for all partners, but mainly being beneficial for our common environments. And we, from the last trials which have been taking place here in March on our pilot line, we have made a small video. Just let's have a look.
Let's take a look.
Yeah.
Today we are running trials with our customers with biopolymers. Those polymers are very interesting because they are made in many cases out of natural resources, and they are also compostable or even home combustible. So with those polymers, it could be possible to improve our carbon footprint.
Interesting insights into the fascinating world of biopolymers with Dr. Martin Wolf. Martin, thank you very much.
You're welcome, Peter. It was nice to be here. Thanks.
Global plastics consumption will quadruple by 2050. In the EU, packaging waste increased by 20% in the last 10 years, and by 2030 it will increase by another 20%. In addition, In Europe, around 40% of post-consumer plastic waste is incinerated with energy recovery. Around 25% is still landfilled, and only approximately 30% is recycled. So let's talk about waste regulation. And for that, welcome back, Dr. Markus Koppers. Hi, Markus.
Hello, Peter.
Finally, the EU reacts.
Yes, they really do. And they are really going against this catastrophe. And what has happened is in November, they just published the first version of the packaging waste regulation. And this is so important because regulation means a regulation will overrule national law. So we really have to be aware here is something coming. So it's not in force yet, because this year we have the legislative process. Next year we have the adoption and the entry into force, and 2025 will be the earliest application date.
Markus, what do we have to expect from this packaging waste regulation?
Hard facts. So first of all, in future, all packaging must be recyclable, and not in lab and not in small-scale lines. It really goes to industrial recycling. Mm-hmm. Secondly, future packaging, monomaterial PET or PE, must contain recyclate. For PET, it's 30%. For polyethylene, it's just 10%. For PET, we do not see any problem because we have plenty of bottle flake recyclate ready to use it in our BOPET film. But for BOP or BOPP, we need good recyclate in good quality. And thirdly, the EU will control this. And for controlling it, they introduce a digital product passport. And this is a label printed onto the packaging, clearly visible, and it can be read out, and it will tell how many recyclate is in, what is the material, and how has it be end used or recycled. And so these are really three strong points.
What about the use of bioplastics in this context?
Oh, I always thought bioplastics has no importance in EU, but they really changed. They made a turn back. And what will come that all tea and coffee bags or coffee capsules have to be recyclable. So no aluminium in the bio bin anymore. Also important is lightweight plastic carrier bags for vegetables we see in the supermarket. They will be, and they have to be, biodegradable, in the case industrial biodegradable. And finally, all the adhesives and bundles we see in vegetable packaging, they also have to be industrial compostable. And the EU really has a good idea with it, a good idea behind, by separating bioplastics to the vegetables. They separate it from recycling. So it's dedicated for composting.
What does all of this mean for Brückner?
So first of all, the packaging market is turning upside down. And we will supply solutions for this market standing just on top. And first of all, we are going for bioplastics in stretched film. We try to make labels. We try to make biodegradable packaging. Secondly, we have our R-Cycle project supporting the idea of a product passport. We even work harder on monomaterial structures made of PP, PE, and PET. And we also strengthen our capacity to handle recyclates on our lines, which is really, really a hard business. And last but not least, we cannot do it just on our own. So key will be partnerships for future cooperation and solutions.
That's it on waste regulation and Brückner's challenges and chances within that complex topic. Markus, thank you very much.
Thanks, Peter. So for us, it's really hard and good work.
So that's it for today's edition of Sustainability TV. Thank you to all of my 3 guests, and I'm looking very much forward to seeing you again soon.